How are you, my dear learners? I am going to conclude on the preparation of salts. This is soluble salts using neutralization. And when I finish, I think I am going to proceed to the new subtopic. Now, remember, we talked about soluble salt being prepared by reacting metal hydroxide insoluble metal hydroxide insoluble metal oxides, and lastly we said using metal carbonate. We talked about the preparation of soluble salts from metal hydroxide, which are mainly in aqueous state, and we also discussed the preparation of soluble salts from insoluble metal oxide such as copper 2 oxide. Then we remained with how we can prepare a soluble salt from a metal carbonate. And this is what I am going to discuss in this video. Now, you need to recall that I explained why metal carbonates are used in reactions. Before I even continue, I am going to underline our point number C. At this level, we are going to react a metal carbonate with an acid to produce salt, water, and carbon dioxide, where a salt is going to be our major products, while water and carbon dioxide will be our minor products. Now, in the definition of neutralization, we defined strongly that it's the reaction between an acid and a base to form a salt and water only. But we also need to understand that we can prepare a salt from metal carbonates. Now, when we are using metal carbonates, we are going to add an addition of carbon dioxide as the product apart from salt and water, because in a metal carbonate we are going to have a carbonate which will be a source of carbon dioxide. Therefore, we are going to have carbon dioxide being produced as one of the minor products. In this case, why are we using metal carbonates? My dear learners, you need to understand that all metal carbonates are bases. Therefore, in reactions, metal carbonates react just like bases. You need to understand that. Why are we saying they react just like bases? I want you to look at this simple equation I am going to come up with. I'll go back and give you the definition between a strong base and an acid. I am going to get sodium hydroxide reacting with, for example, sulfuric acid. What happens when base or an alkali is reacting with an acid, the ions are paired according to their charges. For example, in solution of sodium hydroxide, when we mix it with sulfuric acid, the sodium ions will react with a sulfate ion to form sodium sulfate. This will be the salt which is going to be formed. Now, when we form this salt, it means in solution we are going to remain with hydroxide and hydrogen ions. Now, the hydroxides are negatively charged, the hydrogen ions are positively charged. And where we see these, we just know that hydroxide and hydrogen react to form water. Meaning there's an attraction between the hydroxide and the hydrogen, more especially that in the hydroxide there is oxygen which has high affinity to attract the positive charge. So provided we have oxygen in the structure, that oxygen in the hydroxide has higher affinity to attract the positive charge of the hydrogen, and that forms water. Now, when we are reacting a carbonate, the same happens, where metal carbonate behaves just like a base. That's the reason why carbonates are bases. And in most cases, these basic salts are prepared by reacting the weak acid with a strong base. For example, when we have magnesium carbonate, it means we reacted the carbonic acid, which is a weak acid, with a strong base, magnesium hydroxide. Now, since the base which is going to be used is very strong, the name of the salt is going to be related to a base, because the salt is going to be more basic than normal. And this is what happens during the chemical reaction. So I am saying we are going to have a metal carbonate, magnesium for example. Magnesium in this case is positively charged, and a radical carbonate is 2 negative. Now, when we get another acid, or we get a pair of acid, for example, sulfuric acid, and then we put the solid magnesium carbonate to sulfuric acid, the magnesium carbonate first is going to dissolve. When it is dissolved in sulfuric acid, the ions will be able to move. Now, when ions are able to move, it means the positive magnesium ion is going to react with a sulfate of an acid to form a salt known as magnesium sulfate. Now, when that happens, we are going to witness that we are going to remain with hydrogen ions and the carbonate. The presence of hydrogen ion and the carbonate is going to cause the following to happen. So we are going to have a carbonate reacting with hydrogen ions from an acid. just like the hydroxide and an acid, meaning this carbonate is behaving like a base. In the same way, the hydroxide, this side, is basic. How is that possible? This oxygen of the hydroxide is going to get this hydrogen ion to form water. In the same way, one oxygen atom from a carbonate is going to attract this hydrogen ion to form water. Now, when we subtract one oxygen atom from carbon dioxide, we are going to remain with two atoms of oxygen bonded to one atom of carbon, and that now will be what we call carbon dioxide. That's the reason why we are saying a carbonate is also basic. That is very important. Moving forward. So we are going to prepare magnesium sulfate, for example, and we are not saying you can only be given to prepare magnesium sulfate. You can be given to prepare any neutral salt, but what is important is the procedure, and I'm telling you that the procedure is going to be the same, only the reagents we are going to use will be different. In this case, we are using magnesium carbonate because magnesium carbonate will give us magnesium, and a sulfuric acid will give us the sulfate. So if they want you to prepare magnesium for, should I say, sodium sulfate, you are going to use sodium carbonate because sodium carbonate will give you sodium. So what is important is to understand questions, and the products which are going to be formed will be magnesium sulfate plus water plus carbon dioxide, as you can just see. And the reaction is given. I have explained what happens when magnesium carbonate is reacting with an acid. Method. Just like this, the procedure we used when we are preparing copper 2 sulfate from copper 2 oxide and sulfuric acid. The same procedure is going to be used, only that we are going to be changing the reagents. Where we are putting copper 2 oxide, we'll be putting magnesium carbonate. But the procedure is going to remain the same, as you are going to observe in my explanation. So we are going to start with putting sulfuric acid in a beaker, and we need to make sure that we warm the acid but not to boil it. And the same scientific explanation is going to be given. This magnesium carbonate will be in solid state, as you can observe there. Therefore, in order to increase the rate of chemical reaction, we need to increase temperature on the acid, so that by the time we are going to add magnesium carbonate, it is going to dissolve at a faster rate. And the faster magnesium carbonate is able to dissolve in sulfuric acid, the faster the rate of chemical reaction will take place. Reason being that with high temperature, we are going to increase the kinetic energy of particles, and when we increase the kinetic energy of particles, we are also increasing the effective collision of particles between magnesium carbonate and sulfuric acid. As the orientation changes, there will be the high chance of sulfate and magnesium ions with the opposite charges to react chemically to form magnesium sulfate. We are also saying we are going to add magnesium carbonate in excess, and the reason is just the same, to ensure that all the sulfuric acid are converted to a salt. We'll still stir the mixture and filter to have a clear solution of magnesium sulfate. Magnesium sulfate is not going to be blue in color because magnesium is not a transition element. This is going to be a colorless solution. Now, the solution that is going to be formed in the first place is not going to be clear because it is going to contain the excess magnesium carbonate. So since we are going to have excess magnesium carbonate that is not going to react, we need to filter out the mixture so that we can remain with a clear solution of magnesium sulfate. Since we are interested in the solid magnesium sulfate, we need to continue to the second stage, where we are going to evaporate excess water from the clear solution of magnesium sulfate so that we can evaporate excess water. When we evaporate excess water, we are going to form what we call a saturated solution. By cooling the saturated solution formed, we are going to allow the crystals of magnesium sulfate to form. And when we dry the magnesium sulfate crystals, we are going to come up with an hydrated salt of magnesium sulfate. And when you manage to do that, it means now you have finished the procedure on how you can prepare magnesium sulfate. We can look at an exam question which has been given in form of an exercise. The following procedure was used by Darlington Naumsa Jr. to prepare magnesium sulfate crystals. Dilute sulfuric acid was put in the beaker, and an excess of magnesium carbonate was added to the acid. The mixture stirred and filtered. The filtrate obtained was evaporated to half of its original volume. The filtrate was then cooled in the ice bath. And then we can look at the questions. State why excess of magnesium carbonate was added to dilute sulfuric acid. My dear learners, you should be able to pause the video and answer the question. So we are saying we are going to add excess magnesium carbonate in order to neutralize or to ensure that sulfuric acid is completely converted to magnesium sulfate. So to ensure that all the acids are neutralized and converted to magnesium sulfate, that's the reason why excess magnesium carbonate was added. The reaction mixture was filtered. This one is to remove excess magnesium carbonate. You forgive me because of space. I am going to use just a vernacular chemical symbol of magnesium carbonate there. So you need to be smart to remove the unreacted excess magnesium carbonate. That's the reason why we need to filter. The filtrate was evaporated to half of its original volume. This was to ensure that the saturated solution is formed. In order to form a saturated solution, the filtrate was cooled to form the crystals of copper, magnesium sulfate. So this must be very simple for you, my dear learners, because the answers are just coming from the procedure of preparing magnesium sulfate. So you need to understand, very important, I am not going to start a new subtopic. I will allow you to go through the same preparation of magnesium carbonate as you coordinate it to what we discussed in the previous video. I would like you to continue subscribing so that you continue benefiting from my scientific explanation of concepts. As at now, I am going to say enjoy the rest of the day. Thank you so much.